So in previous lecture, in our last lecture before we had our holiday break, okay, kita stop dekat resonance structure. Okay, all right. So you have learned how to draw the Lewis structure, and then from the Lewis structure, okay, from the complete Lewis structure, we will proceed to resonance structure if there is any. Okay, kalau ada resonance structure. Sometimes we don't have resonance structure for molecules. Sometimes we do have resonance structures. Okay, all right. So whatever it is, please make sure that your Lewis structure is complete first. Okay, you have to make sure you have to go through all the steps, the calculation step, the distribution of electrons, and then you have to make sure that each of the atoms in the molecules are all octet. Okay, if that is done, then only you proceed with the resonance structure. Okay, you do not go you do not simply have your resonance structure without having your Lewis structure correct. Okay, all right. So these are the rules for resonance structure. So how do we identify whether it is a resonance structure or not? Okay, the first rule will be the atoms in the molecule should have the same connectivity. Okay, only the electron position, the bonding electron and the lone pair electron can be changed. But the connectivity of the atom should be the same, meaning that the central should remain the same and also the terminals. That is what it meant by connectivity, the atoms placement. Okay, if let's say for example HCN, katakanlah that means HCN does not have what do we call that? Does not have resonance structure. This one. Tengok contoh terus. Okay, alright. So NNO, so make sure that you draw the Lewis structure for NNO first. Okay, and then next only you go for the resonance structure. Okay, so your Lewis structure for NNO, N2O is maybe this one. Okay, so another option for this is structure A and structure C. Okay, option for atoms to achieve octet. So it may form double bond between the N and O, or it may form triple bond between the nitrogen and single bond with oxygen, and the other way around. Nitrogen triply bonded to oxygen and singly bonded to nitrogen. Okay, so these are options that we would say for resonance structure. So resonance structures are like options for atoms to achieve octet. Okay, so that is very important. Okay, in order to know the it is a resonance structure or not. Katakanlah tiba-tiba instead of NNO, you tiba-tiba NON. This is no longer resonance structure to this one. Okay, because the connectivity is not the same anymore. Okay, dia disobey the rule. Maksudnya, this NON, okay, has different resonance structure, having NON as the atom placement. Okay, all right. Okay, so we have one checkpoint that we haven't discussed during our last lecture. So I hope that everybody has completed this checkpoint. Okay, I have told you guys before before our next session, make sure that you complete your checkpoint. Okay, so I assume that everybody has completed this checkpoint. Okay, all right, so draw the possible resonance structure for NCO minus. Okay, ion, indicate the formal charges and select the most plausible structure. Okay, all right, so first thing first, you have to draw the Lewis structure for this ion. Okay, so and then from there, once you have the Lewis structure, the complete Lewis structure for this ion, you would go for the resonance structure. And then from those resonance structure, you need to select which of these three. For example, three lah. Normally we would have three resonance structure. Okay, normally it can be more, Okay, normally three lah. So we would want to select between those three structure, which one is the most plausible. Plausible means I would say most preferable ataupun most stable form of the ions. In this case ion lah. Okay, kita kena based on again there are rules that you need to know. Okay, make sure that dia kena the best would be all the formal charges should be zero. Kita akan based on formal charges. Okay, so the best would be each of the atom has zero formal charge. Okay, if possible. Katakanlah we do not have that possibility to have all of them zero formal charge, then we will go for the lowest formal charge possible. Okay, the lowest formal charge possible. And then kalau next thing that you need to consider is the electronegative atom should have negative charge. Okay, so like what we had in example here. Okay, the Lewis structure alone. Okay, the Lewis structure alone will be provided 1 mark. So katakanlah you got all these three Lewis structure is correct. That means you have 1 mark here, 1 mark, and then 1 mark. Okay, so ataupun minimum pun half. Okay, for the Lewis structure. For the resonance structure, sorry guys, for the resonance structure, for each resonance structure, correct. And then you have to calculate for the formal charges. Okay, and then from there, okay, this is most unlikely, betul tak? And then kita kena consider this one. As you can see, kita kena consider the most electronegative atom should bear the negative charge. A is unlikely because oxygen, which is most electronegative atom in the molecule, possess the zero formal charge compared to nitrogen. So nitrogen ni dah lawan Tokay dah ni. Nitrogen should possess positive value. Okay, oxygen should possess the negative value. Tapi dekat sini nitrogen pula more negative than oxygen. Okay, so it cannot be like that. So it should be the other way around. That is why A is not possible. B is most plausible. Okay, so that is one thing that you need to consider. Okay, all right. So from this, you have to draw the Lewis structure. Okay, start from the beginning. So we have to decide nitrogen, carbon, and oxygen based on the electronegativity given. Okay, we would decide that carbon would become the central. Okay, so kita placement of the atom first. Okay, this. So we have nitrogen, oxygen. So this is an ion, right? So prepare the bracket and also the charge. Okay, so this is the skeletal, and then we total up all the electrons. The valence electron for nitrogen will be 5 electron. Carbon would be 4 electron because carbon come from group 14. Okay, do not get confused with 6 electron. Okay, carbon 4 electron. And then oxygen, we have 6 electron. Okay, all right, total up we have 15 electron. Okay, as you can see, this is an odd number. Okay, normally we would get even number. Okay, so they mesti even number lah. So that is why you need to consider the charge. Because to charge the -1 charge kan. Alright, that means you have to total up. Total up, okay, the charge. So in this case, it's -1. That means you have to add 1 electron. If it's -2, that means you have to add 2 electron. If it's -3, that means you have to add 3 electron. If it's +1, okay, if it's +1, that means you have to minus 1 electron, guys. Okay, if it's +2, that means you have to minus, instead of plus, it will become -2 electron. And so on. Okay, so please take note on that. Jangan asyik-asyik tambah aja kerjanya. Tambah is for an ion. Okay, an ion. Minus is for cation, because cation remove its electron. Okay, all right. So there we have 16 electrons. So this 16 electron first will be minus with the bonding electron. So we have 2 bonds there, which equivalent to 4 electrons. So this is bonding electron. So we have 12 electron available. Okay, next will be to distribute, okay, to the terminal electron. So 1, 2, kita octetkan the terminal atom first. 3, 4, 5, 6. So in total we have 12 electron. So we have used all the 12 electrons. So this is for terminal electron, and we have none electron left. Okay, all right. Next step is to make sure that each one of them achieve octet. Kena lalu that process first. Okay, all right. So as you can see, nitrogen is octet, and the same goes to oxygen, but not for carbon. So we have to make sure that carbon achieve octet first. Okay, all right. So here kita ada banyak option guys tu. Katakanlah you would go for double bond between carbon and oxygen, double bond between nitrogen and carbon. Okay, katakanlah this one, okay, kita jadikan dia double bond, and same goes to this one. So this one will not be appearing anymore because dia dah jadi double bond. Dia dah jadi bond. Okay, alright. So N double bond C double bond O. Okay, so this would be your Lewis structure lah. Okay, complete Lewis structure. Okay, katakanlah that one would be your first resonance structure. Okay, this is your first resonance structure, and then you have to prepare. Okay, then only you go for resonance. Okay, dah ready your Lewis structure, then only you go for resonance. Okay, so for your resonance options, okay, for alternative for all of these atoms to achieve octet is by having triple bond with nitrogen and single bond with oxygen. Betul tak? Okay, so in this case dia akan jadi 6 balik. This one dia akan ada 1 lone pair and triple bond, and carbon should have no lone pair at all. Okay, so this is the second alternative. As you can see, everybody is octet still. And the third would be the opposite of this one lah. Okay, so the oxygen will be having the triple bond with carbon. Okay, all right. Yep, triple bond. Okay, O, 1, 2. Okay, don't forget the charge. All right, so please make sure that every atoms are octet. So octet. So these are your Lewis structure. Okay, so if you have all of these correct, that means provided you have the bracket, you have the charge, you have the arrows, you can get full mark for the structure. Okay, all right, then this will be draw the possible resonance structure. So you have answered the first question. The second question, indicate the formal charges. That means you have to calculate the formal charges for each structures, and then you have to select the most plausible structure. Okay, you have to select the most plausible structure, the best one lah. Okay, so in that case, you have to calculate for the formal charges. Okay, all right. So this is your what we call that resonance structure. Okay, like what we had just now. Okay, you have to select. So in this answer dia tak tunjuk the formal charges. So by right you should have your formal charges. And once you have calculated your formal charges, make sure you place them on top ataupun below. Okay, at the bottom of the atoms. Katakanlah this one is 0, this one is negative, this one is negative 1, this one is positive 2. Katakanlah contoh-contoh Okay, alright. So place them on the Lewis structure itself, on the resonance structure itself, so that it is easier for the examiner, okay, for the examiner to refer to. Okay, alright. So can someone please read out the formal charges that you have calculated for all the structure here? For structure 1, I know the carbon will be 0. How about the oxygen? What is the formal charge for oxygen here?
1.
+1 or -1?
Positive.
+1. And then how about the nitrogen here?
-2.
-2 Just to check, okay, just to check. Saya rasa semua tahu kot, I've mentioned this. You can check whether your formal charges calculated are correct ataupun wrong. Okay, so make sure that when you total your formal charge, it should be the same as the charge, the overall charge. So -2 plus 1, it will be -1. So it is the same. Okay, dia sama lah, unless somehow kalau nak salah itu orang kata malang lah, malang kejadian malang. That is very unfortunate. Somehow you dapat sini 3 and then you dapat sini +2. -3, +2, still you got -1. Tapi still salah. Okay, so that is one of the alternative for you to check your formal charges. Okay, how about structure 2? This one also 0. How about N? Double bond N? Which C?
-1.
-1. And then how about O?
0.
0. Sorry. Okay. Alright. This one, structure 3. This one is 0. Nitrogen?
0.
0. And then this is -1.
-1.
Okay. Right. Okay. So roughly kita tengok, okay, dia sama negative. It will be, the total charge will be -1, which is the same. This one also. Okay. So the most unlikely one, okay, the most unfavorable ataupun unlikely lah, yang sangat tak unpreferred adalah structure 1. Because kenapa? Because the nitrogen, as you can see, nitrogen has the highest formal charge. So this is very unlikely. Out dah awal. Okay, alright. Okay, now to compare between structure 2 and structure 3. Okay, we have to decide. Okay, we cannot compare in terms of carbon, obviously, because both of them have the same formal charge for carbon. In fact, for structure 1 also, we have carbon formal charge equal to 0. Okay, alright, so we have to consider the electronegativity of the atom in the molecule. Okay, let's look at structure 2 first. As you can see, oxygen has a 0 formal charge, which is good, but nitrogen -1. Kat sini oxygen marah lah. Okay, ni dah lawan tokey ni. So oxygen should bear the -1 because oxygen is most electronegative in this molecule. Okay, alright. So structure 2 is also unlikely, okay, unfavorable. So we go for structure 3. Okay, tak kisahlah kalau you punya structure 3 adalah your first structure, second structure, doesn't matter. Because we will refer on your Lewis structure. Okay, so doesn't matter you need structure 3 in the answer scheme, but your answer, you have structure 3 as your structure 1. Doesn't matter, tak kisah. Okay, because at the end of the day, you should have these 3 resonant structure. Okay, alright. So you would choose structure 3 as your most plausible structure. Okay, you may label it as A, B, C, 1, 2, 3, or whatsoever. Okay, doesn't matter, but please make sure that you highlight which one is the most plausible structure and then give reason why. Okay, give reason why. Okay, so structure 3, which places a negative charge on oxygen, the most electronegative of the 3 element in the most plausible Lewis structure, or yang sewaktu dengannya. Okay, it's because of oxygen bears the -1 charge, because oxygen is more electronegative or something like that. Okay, right. Any question?
Madam?
Yes.
Kalau untuk resonance structure, memang kita tengok yang dekat, yang which one of the atom yang negatif tu
Normally. Okay, dia punya tricky part adalah part tu. So we will go for that. If let's say lah, normally kita punya style exam question is like this. Okay, katakanlah you got apa nama tu, -2. Katakanlah dia ada 2 resonance structure je. Okay, you still have to consider for, okay, we will go for 0. Okay, we will go for 0. If we have 0, all the formal charges are 0, that means we will go for that. Tapi kalau tak ada, next thing would be we will go for smaller formal charge. Okay? So kalau tak, so kita dah dapat smaller formal charge, one thing that you should consider is electronegativity. Ini pun dia kena berjalan serentak lah benda ni. Okay, so that's why dia masuk dekat rules of resonance structure just now. You cannot just consider one factor, you have to consider all those three. Sometimes you would go for zero, then zero tak ada, and then we will go for the second rule, third rule, okay, and in combination of those three.
Tapi resonance structure memang ada formal charge yang sama je kan? Kalau ikutkan.
Formal charge yang sama, maksudnya ni tak sama?
Maksudnya yang total formal charge dia tu.
Total formal charge mesti kena sama. Cuma macam mana dia dapatkan negatif tu. Contoh, negatif 1 boleh juga negatif, okay, to get negative 1, ada macam-macam cara nak dapat negatif 1, betul tak? Negatif 1 plus 0, negatif 3 plus 2, kan? Macam-macam cara, you still get negative 1. Okay, but our concern is how do we get negative 1? Macam mana dapatkan negative 1? Is either oksigen ke, sorry tersebut pula, oksigen ke yang base negative 1 ataupun nitrogen ke yang base negative 1. Okay, so that is the detail part that we should know lah. Faham tak?
Okay, faham.
Yang tu memang basic lah, maksudnya you dah kira the formal charge. You kena make sure, kadang-kadang kita short sendiri kan, kita calculate, tersalah pula formal charge kita tu. Okay, macam mana kita nak check whether the formal charges that we have calculated just now is correct ataupun wrong. Okay, one of the tip is to make sure that the total formal charge should be the same as the charge. Kalau dia charge dari 0, that means the total formal charge when you total up, it should be 0 lah. Itu just to make sure that you are on track lah. Itu belum lagi you pilih which one is the most possible one. Itu just nak make sure betul tak you calculate formal charge ni. Tapi kadang-kadang keadaan malang tu still boleh berlaku. Macam saya cakap, you want negative 1 kan, somehow you terkira sini negative 3 and then sini you kira positive 2. You still get positive negative 1, betul tak? You still get negative 1. Okay, and then you akan remain this formal charge as your answer. You takkan tukar sebab you dah check. Ini yang kita kata malang. Okay, tu memang malang lah, maksudnya hint tu pun salah. Okay, so ini kata kurang doa lah. Okay, kena banyak doa. Alright, any other question? Hope that answers your question. Okay, whoever asking just now. Any other question related to resonance structure? Resonance is also a favorite question asked in the exam. Okay, so this kind of question. Yep.
Arrow tu memang kena tulis ke? Kalau tertinggal terlupa.
Kena. Okay, kena. Sebab because this arrow represent resonance structure. Last time we did minus mark. Okay, those students who did not include the arrows, we minus mark. Okay, for that. So kena include the arrow. Kena complete lah, senang cerita. You cerita resonance structure kan, you should include the arrow. Bracket, kalau ion, if it's involve ion, then you forgot the bracket, lagi sekali tolak markah. Okay, so normally kita akan tengok, okay, oh ni tak buat what do we call that, arrows, half mark. Tak buat bracket, half mark, tolak, half. Berapa banyak? Satu je, katakanlah you have this bracket for structure 1, then structure 2 you forgot your bracket, sorry, tolak. Dia is either half or 0. Okay, dia salah satu you tak complete, 0 for that particular part lah. Okay.
Okay, thank you, madam.
Alright. Any other question? Okay, right. Okay, let's move on to next subtopic, exception to the Octet Rule. Okay, exception maksudnya pengecualian kepada octet rule. Remember in chemistry we have a lot of abnormality. Maksudnya dia tak follow the way it's supposed to be. Okay, it's okay. Itu yang kita panggil exceptions. Maksudnya ada benda-benda yang we should know lah. Okay, we should take note on this. Okay, so we know that octet rules all elements in the periodic table, they tend to go for octet configuration. Because why? Because it's the most stable form of electron configuration. Maksudnya macam group 18 kan, everybody want to become like group 18. Okay, because it is stable. Okay, alright. However, we have some exceptions. Okay, few exceptions to this octet rule. Remember, the reason they nak achieve the octet is because of the stability. Somehow, even though dia tak achieve the octet, okay, they still stable. Okay, they are still stable. So itulah exception to the octet rule. Okay, alright. So exception to the octet rule. So we have 3 types of exception. One is incomplete octet, maksudnya it has less than 8 valence electron. Okay, incomplete maksudnya tak cukup lah. Expanded maksudnya expand. Okay, so the element or we are focusing. Okay, exception to the octet rule ni is focusing on the central atom, not on the terminal atom, because kita punya steps tu we have octet the terminal. Lastly, we will go for, kalau ada balance electron tu, then only we will go for, kita distribute the remaining electron to the central. Okay, so sometimes the central may have less than 8 electron, sometimes the central may have more than 8 electron. Okay, so this is what we call expanded octet. And then we have the third one is odd number electron species. Okay, I hope by now you should have noticed that normally dia punya lone pair tu, dia punya kiraan lone pair tu normally even number, genap, nombor genap. Perasan tak? Tahulah perasan ke tak perasan kan? Perasan tak? Contohnya this structure 1. Okay, nitrogen 2, 4, 6. Carbon has no lone pair, oxygen has 1 lone pair, 2. Same goes to structure 2, 2, 4. Same goes for oxygen, 2, 4. Okay, nampak tak? Semuanya genap. So opposite to that, we have odd number electron species. Okay, but this odd number electron species, we have this molecule, we have this type of molecule, but it is unstable. This is unstable. Tapi dia exist. Dia exist dia bukan tak boleh, dia boleh tapi dia unstable. Okay, this is what we call free radical. Maksudnya it has 1 unpaired electron. It is known as free radical and it is very reactive. Okay, alright. So let's go back to incomplete octet just now. Okay, you have to remember the elements that can have incomplete octet. So we have beryllium, boron, and aluminium. So when you see these elements, okay, you see chemical formula having this element in it. So don't try to octet them. Jangan pandai-pandai octetkan dia. Okay, sebab remember proses kita last kali kan bila kita calculate and then kita dah place all the electron and whatsoever kan, and then lastly we need to check whether each of the atom tu octet ke tak kan. Tapi for beryllium, boron and aluminium tak perlu octetkan dia. Maksudnya in order to octet the atoms, we normally form multiple bond, double bond or triple bond. Betul tak? Tapi untuk beryllium, boron and aluminium, we do not have to form multiple bond for this atom. Let it be as it is. Jangan usik, jangan ni tak cukup ni. Contohlah beryllium chloride, okay, beryllium chloride, BeCl2. So when we draw the structure, kita akan dapat macam ni. The Lewis structure, kita go through lah all the process and whatnot kan. Okay. Okay, this is the Lewis structure for BeCl2. Okay, alright. So kita akan ada tendency to, kita nak octetkan dia because beryllium as you can see has yet to achieve octet. So kita akan form this double bond, lone pair from Cl will form double bond with beryllium. Please, okay, please refrain yourself from doing that. Do not do that. Okay, this is special beryllium, boron, aluminium. You just leave this molecule as it is. Inilah structure dia. Okay, walaupun dia tak achieve octet, dia dah stable. Macam mana tahu you stable? You kira apa guys? How do you know this is the most preferred Lewis structure for BeCl2? The ultimate way is by using
Formal charge.
Formal charge.
you kira formal charge. Bila you kira formal charge dalam keadaan Be, beryllium having 2 bonds, you akan dapat 0. Cl for both Cl pun 0. Nampak tak? All zeros. Okay. Kalau you try to form double bond, jadi macam ni, you cuba kira formal charge. You tak akan dapat 0. So that is why jangan pergi tambah multiple bond for beryllium, for boron and aluminium. This is what we call incomplete octet. So for for you to remember easily, mungkin boleh guna ni. Bebal tak mau jadi octet kan. So bebal, beryllium, boron and aluminium. Okay, alright. So beryllium, of course, there's no lone pair. Boron and aluminium also has no lone pair. Okay, maksudnya dia memang tak cukup, dia less than 8. On the other hand, expanded octet, the opposite to incomplete octet, it has more than 8 valence electron. The central, we are focusing on the central. Kenapa? Okay, kenapa? Because of the empty d orbital. Okay, this is only possible, syarat dia, this is only possible for elements, mungkin boleh tambah buat sini, for elements come from period 3 and above. Okay, kenapa? Remember, we have learned this in topic 2, n is equal to 1, we only have 1s. N is equal to 2, we only have 2s and 2p. N is equal to 3, we have 2s, 2p, 3s, 3p, and 3d. Okay, that means for n is equal to 3, it can be expanded when it is necessary. Because, kenapa dia boleh expand? Because it has a d orbital. Okay, starting daripada period n is equal to 3 and above lah. So dia dah ada vacant ataupun empty d orbital. The electron can be added into the d orbital. That's why dia boleh expand. Okay, for n is equal to 2, dia tak boleh expanded octet. Contoh n is equal to 2, element that come from period 2 is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So this element, dia follow octet. That's why lah carbon mesti follow octet. Fluorine, oxygen follow octet. Dia tak boleh expand. Okay, because they come from n is equal to 2. But chlorine can expand if necessary. Bila perlu, dia akan follow octet. Tapi kalau perlu, dia boleh expand. Faham tak? Janganlah mesti, dia ni kena expand. Every time kena expand. Not necessarily. Bila perlu saja. Okay? Alright. So, expanded octet can only be formed by elements coming from period 3 and above. The reason why, because there is a vacant d orbital ataupun empty d orbital. Okay, alright. Last but not least will be odd number electron species. Okay, later on kita akan tengok examples of these exceptions. Okay, this is overview so that you get the first idea on what is incomplete octet, expanded octet, and odd number electron species. Okay, so like I said, have one unpaired electron, free radical. It is not, this one is known as free radical, and it is very reactive. Very reactive means it is unstable. Okay, alright. Example NO, NO2 and ClO2. Nampak macam, tak sangka NO ni ataupun NO2 is an odd number electron species kan. Nampak macam sihat je kan. Okay, ClO2, tak sangka ClO2. Rupanya dia odd number electron species. Okay, alright. So let's look at one by one. So incomplete octet, example of BeH2 and BF3. So berbalah. Okay, so draw BeH2. How do you draw BeH2? So this is how you draw BeH2. Macam biasa, go through all the calculation, the process and whatnot. Okay, alright. So this is the structure of BeH2. As you can see, beryllium has only 4 electron dekat dia. Nampak tak? 2, 4. So let it be. Jangan usik. Jangan pergi hydrogen lagi lah, tak logik kan. Hydrogen mana ada lone pair dah untuk nak form multiple bond. Jangan pergi pandai-pandai ada double bond pula kat situ. Okay, and same goes to BF3. So nampak, as you can see, boron has only 6 electron. Okay, let it be. You tak percaya, you try kira dia punya, what do we call that, formal charge. You akan dapat all of them have 0 formal charge. Okay, kita boleh consider as stable form lah of BF3 of the molecule. As you can see, dia calculate sampai total kan. That's why saya ajar awak sampai make sure that you got 0. All the electron have been placed in the molecule. Okay. This is expanded octet, guys, SF6. So this is quite obvious. Okay, sulfur is the central. Fluorine, we have 6 fluorine atoms surrounding sulfur. So 6 fluorines means we have 6 bonds. 6 bonds times 2 is equivalent to 12 electron. Betul tak? 12 electron pada sulfur, that these 6 fluorine atoms are bonded to sulfur. Okay, so obviously dia ada 12 electron lah dekat sulfur ni. So that is what we call expanded octet, more than 8 electron. Okay, sebab dia bonded with 6 electron, 6 fluorine atom. ClF3, okay, this one looks normal, nampak macam follow octet je kan. Be careful. Bila you buat, kita memang akan bagi soalan molekul-molekul yang membuatkan you macam wonder. Ini follow octet ni. Macam maksudnya dia bukan exception. Okay, sebab you nampak, F ni 3. Mesti dia ada satu lone pair. Cukuplah 3, maksudnya 3 bond, 3 bonds, and then you have 1 lone pair. So 8 electrons on chlorine. This is chlorine, chlorine, fluorine. Okay, alright. So then you kata, this one follow octet. Without drawing the Lewis structure. So please be careful dekat situ, you dah salah. Okay, whatever it is, you have to draw the Lewis structure. Unless you dah buat banyak sangat practice, okay, by looking at the chemical formula, you automatically know, okay, you tahu, then it's okay lah for you to I mean, you have your justification. Okay, you have practiced this molecule before. Dan tak apa, kalau rasa-rasa macam bajet-bajet, macam aku tengok pun tahu ni, tanpa buat latihan yang banyak, so jangan berangan. Okay, so this is the structure of ClF3. Nampak tak? So dia sebenarnya, this chlorine, bila you buat this calculation, you akan after you have minus with the bonding electron and the terminal electron, you akan ada baki 4 electron. So that 4 electron will be placed on the central. So cuba totalkan how many electrons on chlorine now? 2, 4, 6, 8, 10. 10 electron, which is more than 8. That means this chlorine is now having expanded octet. Okay? Faham? So my advice to you is to draw whatever it is, just to be confirmed, draw the Lewis structure for the compound given, just to be safe, okay? Sebab you kena, kita examiners ni, kita akan bagi soalan, bukan kita yang pembuat soalan ni, kita akan fikir tempat-tempat yang student akan ada probability pandang remeh, macam take for granted tau. Kat situ yang kita akan tackle. Okay? Kita akan bagi soalan-soalan yang tricky part lah macam tu. Sebab student akan take for granted. Okay? Last but not least will be odd number electron species. Okay, for odd electron numbers, odd electron. Okay, this one NO kan. NO, how do you draw this? Okay, normally dia ada 2 atom saja. Tahu tak? Normally, the minimum atom yang kita dah buat so far, okay, we have 3 atoms. The central and 2 terminal atoms. But this time, kita ada 2 je atom. So, obviously we do not have central lah kan. Tapi ada, kita kan still we have to choose atau we have to select which of this atom will behave, they behave sebagai central. Okay, sebab apa? Nanti kan kita nak buat calculation tu kan, kita kena bagi pada terminal, kita kena bagi pada siapa dulu. Okay, so in this case kita akan go for nitrogen as the central lah. Okay, alright. You nampak tak? Okay, what's the difference NO. So katakanlah kita start from the beginning NO. Okay, alright, NO. There's no charge. Okay, so there should be no bracket. Okay, this is the skeletal, and then we total up the valence electron. Nitrogen has 5 electron, oxygen has 6 electron. As you can see, the total is 11 electron. Nampak tak? Dia odd. Dia dah ganjil kat sini. Dia dah pelik dah dekat sini. Normally we would get even number dekat sini. Okay, kalaupun dia ion pun kita akan totalkan ataupun kita tolak based on the charge. Tapi ini there's no charge here. Okay, tak ada charge untuk kita nak tolak ataupun tambah dekat situ. So dia memang 11 electron. So dah pelik dekat situ. So dekat situ kita boleh tahu dia odd number electron species. But if you were asked to draw the Lewis structure for NO, how do you draw it? Okay, how do you draw it? Okay, so 11 electron macam biasa minus the bonding electron first. Okay, so we have 1 bond. That means we have to minus with 2 electron. This is the bonding electron. Dekat 11 minus 2 berapa? 9 electron. Okay, alright. So dekat sini 9 elektron ni kita kena bagi kepada siapa dulu? Sebab dia dua-dua orang terminal kan. So who would be this 9 electron, okay, kita distribute to oxygen or nitrogen first, guys?
Oksigen.
Okay, kenapa oxygen?
More electronegative.
Yes. Okay, more electronegative. That means nitrogen, dia behave sebagai central lah in this case. Okay, central means bila ada remaining electron, then only we give to central. Kalau ada baki, if there's no baki, that means nitrogen, the central would have no lone pair. Okay, because there's no balance, no electron remaining. Okay, so we have 9 electron. That means we try to octet the oxygen first. Okay, then only we go for nitrogen. Because kenapa oxygen is more electronegative? Oxygen would behave as terminal electron. Kita follow step yang kita buat calculation tu, jangan ubah. Do not change anything. Okay, alright. So kita octetkan dia. So we have 6 electron. We have used 6 electron. So we have another 3 electron remaining. So these 3 electron next will be given to nitrogen. Okay, so 1, 2, 1. Okay, so we have used all the 3 electrons. So we have 0 now. Okay, alright. So okay, kita ada 2 possibility. Tadi ada student tanya masa first lecture session saya. Why not kita let it be as is macam ni? Kenapa kita nak form double bond as what we have here? Nampak tak dia form double bond? Okay, alright. Kita nak maximize the electron share. Kita nak maximizekan dia. Okay, for this one, tengok nitrogen. Oxygen is not a problem. Oxygen still octet. Nitrogen yang dia akan ada masalah nak octet lah sebab dia odd. Okay, nitrogen perlukan lagi berapa elektron in order to, to be close to octet. So 1, 2, 3, 4, 5. Dia dah ada 5 elektron at the moment. So it requires 3 more elektron. Dia perlukan 3 lagi elektron. Betul tak? Okay. If kita form double bond, okay, katakanlah this oxygen. Oxygen yang orang yang jangan pergi form nitrogen, form double bond dengan oxygen jangan ambil lone pair daripada nitrogen. Ingat kita nak apa? Kita nak octetkan the nitrogen. So janganlah pergi ambil lone pair daripada nitrogen. Okay, kita nak bantu nitrogen to achieve octet. So we take the lone pair from the terminal atom to help the central to achieve octet. Okay, to help the central to achieve octet. Walaupun tak dapat tapi at least close to octet. Okay, so bila dia form, dia akan jadi begini. So oxygen now has 2 lone pair, but 2 bonds, with 2 bonds. Okay, ataupun double bond. Okay, so this one dia remain lah. Jangan pergi tukar pula. Okay, alright. So now try to calculate for nitrogen. Oxygen is not a problem because dia dah octet. How about nitrogen? Nitrogen is now having 2, 4, 6, 7. Dia dah ada 7 elektron. That means it requires 1 more electron in order to achieve. This one 5 electron kan. So it requires 3 more electron in order to achieve octet. This one requires only 1 more electron in order to achieve octet. Okay. So the closer it is to the octet, the better lah. This would be the Lewis structure for NO. Okay, not this one. Faham? Sebab ni banyak lagi ni, 3 elektron. This one 1 elektron. Later kalau dia nak form ions, dia hanya perlukan 1 elektron. Kalau you biar dia macam ni, dia perlukan 3 elektron daripada orang lain in order to achieve octet. So that's a lot. Okay, so that's why kita adjust dalam molekul tu sendiri. So that is why for NO it has double bond between the nitrogen and oxygen. Okay, faham ya? So NO we do not have what do we call this? NO kita tak ada charge kan? That's why the odd electron species. But NO minus we do have NO minus. Is it NO minus ataupun NO3 minus? Confused. Okay? So normally kalau dia kan odd, in order to achieve even number, maksudnya to achieve octet, dia kena jadi ions. Dia kena accept electron ataupun remove electron. Okay? Faham ya? Octet. Apa nama benda lah ni? Odd number electron species.
Madam.
Yep.
Kiranya yang single bond tu dikira resonance structure ke tak kira?
Kalau ikutkan kira lah kan. Dia dikira tapi odd number electron species ni dia special case sikit lah sebab dia tak achieve octet. Okay, the one that we have learned for resonance tu dia octet. Normally resonance structure kita yang involve atoms having octet configuration. Okay, octet configuration. So odd number ni kita so far tak pernah tanya lah, tapi saya tak boleh confirm. I cannot confirm that in case you punya batch dia nak tanya pula kan. Tapi kalau based on the resonance rule tu, dia fit kan, maksudnya dia tak violate. Maksudnya the connectivity is the same, it's just that dia differ in terms of electron position. Tadi dalam bentuk lone pair, now dia jadi bond. Okay, ikutkan dia adalah resonant betul tak? Dia ada few structures lah, that we can consider.
Thank you, madam.
Alright. Kita boleh consider lah dia sebagai resonance. Tapi itulah, kita tak go detail on that. Saya pun tak adalah mencari kan so far kan. Now only saya baru perasan Okay, any other question? Okay guys, tak ada question. Okay, let's try to to complete this checkpoint. Maybe you can try on A dengan D. Boleh try on A and D? A and D. Try dulu. B dengan C tu you boleh buat sendirilah later. Okay, try A and D. Okay, I give you 3 minutes for you to complete these 2 checkpoints, okay? We will discuss it at 4 p.m. Okay. Okay, all right. So question 1, draw a Lewis structure of the following molecule and identify the octet rule exception. Okay, the octet rule exception. So you have to draw all of the molecules, and then from the molecule, from your Lewis structure, you have to identify which of them follows or obeys the octet rule, and which does not follow ataupun yang exceptions to octet rule. Okay, alright. So I have asked you to draw for A and D. Okay, alright. So SCl and fluorine. So you have to decide which of these three would be your central. Okay, so these are the electronegativity values for all the atoms present in the molecule, in all of the molecules here. So you would decide, so sulfur has the lowest, 2.5, chlorine 3, fluorine we have 4. Okay, sulfur would be the central, and then the rest are all terminals. Okay, so ini pun agak obvious lah dekat situ. So once we have decided that sulfur is the central, fluorine obviously dah ada 5 fluorine atom. So that means we have 5 bonds dekat situ. Dah ada 5 bonds for fluorine alone, and then we have 1 chlorine, so we have 6 bonds. 1 chlorine plus 5 fluorine, that means we have 6 bonds surrounding the sulfur. So 6 bonds times 2 is equivalent to 12 electrons. So this is what we call expanded octet. Okay, so this is expanded octet. Okay. So this is how your Lewis structure should look like. This is how, okay? So this is how your Lewis structure, and then this is expanded octet. Okay, after all, sulfur come from period 3. Okay, it can be expanded. Okay, so in this case, it is expanded. Okay, then B kita skip tadi. Also NO2. Okay, NO2 is an odd electron species. Okay, macam mana tahu? You have to draw dulu. Kalau based on NO2 tak nampak macam dia pelik pun. Betul tak? Tapi remember, NO2 yang kita pernah deal is NO2 minus. NO2, so this is molecule. Okay, this is free radical ataupun odd electron species. When you draw it, you can see that it is consists of 1. The nitrogen has 1 unpaired electron. Okay, nitrogen cannot be expanded, guys. Okay, boleh beritahu tak kenapa dia tak boleh expand nitrogen? Can someone please explain why nitrogen cannot be expanded? Katakanlah nak form double bond kan dengan oxygen, form triple bond dengan oxygen, still dia tak follow octet. Betul tak? Dia still tak follow octet because of this unpaired electron. But we can form is it possible to form double bond, triple bond dengan oxygen dekat sini for nitrogen, between the nitrogen and the terminal atoms?
Sebab dia period 2.
Okay, because dia period, nitrogen comes from period 2. Okay, itu sebenarnya belum answer dia lagi lah. You have to give reason why. Okay, tapi dia punya pembuka dia, intro dia, because of nitrogen come from group 2, period 2. Okay, nitrogen should obey the octet rule. Okay, sebab n is equal to 2 does not have d orbital. So that's why nitrogen mesti follow octet. Kalau tak follow octet, dia akan jadi odd macam ini. Okay, alright. So this is how your drawing should look like. Okay, dia sama ada dia begini ataupun dia begini. Okay, dia tukar sebab after all we have 2 oxygen kan. So it's either between the double bond between the second oxygen ataupun the double bond is between nitrogen and the first oxygen. Okay, alright. So this is what we call resonance lah. Ni resonance ni. Okay, berubah-ubah tempat. And then BFCl2, okay, this is what we call incomplete octet because bebal, boron, beryllium, boron and aluminium. Okay, remember, betul-betul ingatkan buatlah macam mana. Korek-korek. Saya nak bagi analogi tu supaya awak janganlah salah benda-benda soalan-soalan yang macam ni. Ini macam nak bagi free mark aje lah, boron, beryllium, aluminium. Okay, alright. So as you can see, boron has three bonds. That means it's equivalent to 6 electron only. Okay, but we are not going to form multiple bond with boron. Jangan pergi buat macam tu. Okay, alright. So this is how it is. So this is incomplete. And then last but not least is ClO2. Okay, ClO2 is an odd electron species. Okay, this is how it looks like. Okay, so dia ada the unpaired electron is located on Cl. Faham tak? Macam mana boleh dekat Cl, madam? Kenapa tak oksigen? You kena lalu proses kira-kira tu. Kalau you tak lalu proses kira-kira tu, you akan keluarkan soalan macam tu. Okay, so you should go through the process and then you will end up with the unpaired electron should be placed on the chlorine. Okay, after all we are talking about the central atom. Exceptions to the Octet Rule 2 is for central atom. Okay, alright, so it can be in this form or it can also be in this form. Okay, alright. Ada soalan ke? Any question related to apa ni? Exceptions to Octet Rule just now? Before we proceed to the next subtopic, coordinate dative bond. Coordinate or also known as dative bond. Anyone? Ada. Okay, alright. So, coordinate or dative bond, okay, it is still considered as covalent bond. The word covalent means the sharing, okay. So they achieve octet by sharing the electron. So that is the covalent, that is what covalent means, okay. So now we have coordinate, covalent bond. Still we have the covalent. Covalent means sharing. Okay, but now we have coordinate. The term coordinate here. So what does this mean? Okay, coordinate means macam coordination, macam strategic, macam something yang dah di-plan. Okay, yang dah ada direction. Coordinate something yang ada direction dekat situ. Okay, and it still involve sharing. Okay, bond, sharing the electron. Okay, so a coordinate covalent bond is formed when both bonding electrons are donated by only one atom. Okay, by one atom only. So that is what we call coordinate covalent bond. Okay, alright, so you must compare in order for you to get better view ataupun better idea on what is coordinate covalent bonds. You have to compare it with the normal covalent bond. So what is the difference between these two? Okay, normal covalent bond means each atom must contribute one electron. Betul tak? Okay, katakanlah A and B. So we have A and B. So in order to form a bond, mana A mana B, lupa. Ni A, ni B. Okay, in order to form a bond, A should contribute one electron, at least. B should also contribute one electron. Okay, so they will share. Okay, they share akan jadi satu bond. Okay, this is the conventional, the normal covalent bond. Sharing tu kita panggil covalent. Okay, this is the normal one. Okay, coordinate on the other hand, instead of seorang bagi satu share, both electron is given ataupun is provided ataupun is contributed from only one atom sahaja dekat situ. Instead of dua-dua bagi, only one atom contributes both electron. That is the difference between coordinate and the normal covalent bond. Okay, right. So so we can imagine it as, okay, we have D and A, for example. Okay, this is the donor. D stand for electron pair donor. A stand for acceptor. Sebab after all tadi apa saya cakap, hanya one atom contribute the electron. The other atom tu does not. Okay, so dia akan contribute both electrons. So that is what we call dative bond. So in order to appreciate the donor, that both electron tu datang daripada the donor yang baik hati tu, okay, we represent the bond form by using arrow. Okay, that shows that electron come from the donor. So from the donor to the acceptor. So this is the dative bond. This is what we call dative bond. Dative covalent bond. Dia still sharing ya, still sharing. Okay. Alright, so a coordinate dative bond is represented by an arrow pointing from the donor of the electron pair to the acceptor of the electron pair. So we have electron donor and we have electron acceptor. So what are the characteristics of these two donor and acceptor? So electron donor, in order to donate its electron, at least the donor should have one lone pair. Betul tak? At least dia kena ada one lone pair electron in order to be donated to the acceptor. Logically speaking lah, nak donate mestilah ada benda, ada extra, betul tak? Baru boleh donate. Okay, on the other hand, acceptor which does not have any lone pair, maksudnya dia tak ada lone pair, but dia ada at least one vacant orbital. Sebab dia menerima. Okay, in order to accept, dia mesti prepare a vacant orbital. Okay, a vacant orbital so that the electron donated can be placed into the orbital. Okay, so that's why must have at least, for the acceptor here, must have at least one vacant orbital in its outer shell to receive the electron pair. Okay. Alright, example, okay, this is NH3, this is ammonia. When you draw ammonia, so this is how your Lewis structure should looks like. Okay, so this is ammonia. As you can see, ammonia has one lone pair. Okay, and then hydrogen, H plus, on the other hand, does not have electron. No electron available in H plus. I'm talking about H plus. Okay, that means H plus has vacant orbital. Dia ada vacant orbital lah. Sebab dia tak ada elektron langsung in this case. Okay, dia tak ada elektron. So, this is what we call the formation of dative bond. Okay, so this lone pair from nitrogen, okay, will be shared with hydrogen. Nampak tak? Macam ni. Okay, ataupun kita lebih senang kita pakai macam ni lah. Okay, don't forget the bracket guys. When it accept electron, it will become positive 1 because it has extra proton now. Okay, initially dia charge dia 0, now they become positive 1 because it accepts proton. Okay, alright. So to highlight the dative bond, so you use arrow from the donor to acceptor. Okay, so highlight, label, this is the dative bond. Remember, it's from the donor to the acceptor, not the other way around. Okay? Another example that we can have is again NH3. Okay, NH3 is the donor. In this case, the acceptor is BF3. This is the acceptor. Why is it BF3 behave as an acceptor? In this case, remember, because the incomplete octet. Okay, incomplete octet. Maksudnya boron does not have extra lone pair. Dia tak ada elektron lah. I mean, dia ada elektron yang dah di-share dengan orang lain kan. But boron does not have what do we call that? Lone pairs. Dia tak ada lone pair. And then it has vacant orbital. Dia ada vacant orbital. Okay, dia ada vacant orbital. So, boron as the acceptor will accept the lone pair from the nitrogen, so it will become like this. Ni sepatutnya dah tak ada ni. So sebab dia dah this lone pair has been transformed into bond. So patut dia dah tak ada lah, nanti sekarang pelik, redundant lah guys. Tak boleh Once you have transformed the lone pair into bond, make sure you rub off the dots. Okay, jangan pula dah lah ada lone pair, lepas tu ada bond pula kat situ. Itu by right tak betul tu, salah. Okay, so this is how it should look like. So we have this dative bond pointing from nitrogen to boron. Okay, right. Okay, we also have dimer, guys. Dimer, chemical bonding in aluminum Al2Cl6 dimer structure. So this is what we call application of dative bond. Application of dative bond. So initially dia sebenarnya AlCl3. Okay, AlCl3. When these two combine, okay, dia akan jadi Al2Cl6. Okay, jadi Al2Cl6. So dia punya formation, okay, how do they combine? Okay, how do they combine? So they combine and it will form dimer structure. So what interests us is to see how the bond form. Because we know that aluminium come from incomplete octet, macam boron just now. Okay, tapi how the dative bond can be formed in Al2Cl6. Macam mana? Okay. Alright, so like I said just now, AlCl3, this is what we call monomer. Okay, when these two combine, it is called dimer. Okay, kalau banyak lagi combination of monomer, we can have tu yang akan ada polymer. Okay, di means di lah, dua lah. Okay, so we have two molecules combined. Okay, are linked together through two dative bond. So macam mana nak show the dative bond? Okay, alright. So this is how, this is the first molecule. Okay, AlCl3, like I said just now, AlCl3, and this is the second molecule, guys. Okay, macam mana bond boleh form pula dekat sini kan? So dekat sini, Al is the acceptor. Okay, Al is the acceptor, and Cl, this is molecule 1, this is molecule 2. Okay, Cl from molecule 2 will behave as the donor. Remember sebenarnya dia ada dia ada lone pair kat sini. You kena tunjuk lah sebenarnya. Tapi, so maybe you can tambah, you can add in the lone pair. Okay, so 1, 2, 3, 4. So, Cl, which is the terminal atom or the surrounding atom from second molecule here, will become the donor. So, one of the lone pair for one of the Cl lone pair will be donated to aluminium. Okay, donated as in the dative bond will be formed. Nampak tak arrow dia tu? Okay, alright. On the other hand, how about this aluminium from second molecule? This is first molecule, this is second molecule. Okay, same goes to this one just now. Okay, kita apply for this chlorine and aluminium. Okay, so the chlorine from the first molecule will, the lone pair from the first molecule will be donated to aluminium. Okay, from the second molecule in order to form the dative bond. Nampak tak arrow dia? Begitu. Okay, dia kena from different molecule lah. Dia tak boleh lah datang daripada the same molecule. Right? Okay, ini dia macam sengit sikit kan. You mungkin normally kita akan go for macam ni lah. Normally kita akan lukis macam ni Ni belum belajar geometry memang macam ni lah rasanya you guys akan lukis. Nanti dah belajar geometry, this is not the how you draw it. Okay, this is the first molecule. Okay, and this is the second molecule. So you nak combine kan dia kan? How do you draw the awak macam tu terkejut. Jangan buat begini. Make sure dia punya bond tu betul-betul below. Above. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay? Alright. Remember, it should come from the donor to the acceptor. Okay, this is the first molecule. This is the second molecule. Okay. Aluminium should be accepting electron from the donor. Okay, this from the donor of the first molecule. Okay, alright. So this, let's choose this one lah. Cl ni this one. Okay, so this lone pair will be used. Okay, so kita padam this lone pair. Okay, padam, and it will be transformed into dative bond. It will be transformed into dative bond. Okay, padam lah elok-elok sikit. Padam. Jangan ada dah, sebab dia dah digunakan. It has been transformed. Okay, alright. So this is the dative bond, the first dative bond. And then how about this aluminium from the first molecule? Okay, so it should the donor should come from the second molecule. Okay, let's say kita ambil yang this one, this Cl here, this one. Okay, so this one kita delete, kita padam. Okay, it will be transformed into dative bond. The arrow should be from aluminium, from chlorine to the first aluminium. Okay, jadilah, boleh lah, boleh. Sebab what we want is more on to see how do you form the dative bond between the molecule. Okay, sebenarnya cantiknya memang macam ni. You kena sengit sikit lah. Nampak tak dia punya diagonal tu? Dimer dia tu. I mean macam diamond shape kan? So, tapi tak apa. As long as what is most important is you know that the donor is the chlorine. Okay, the chlorine is donating one of its lone pair to form the dative bond. Okay, between to form dative bond with aluminium, the second molecule of aluminium. Okay, itu yang penting. Okay, tapi it's good if you have if you could draw this kind of structure of dimer. Okay. Right. Okay, draw the dative bond for the following structures. Okay, guys, maybe you can try out B. Okay, are you done guys? Selalu tak tanya kan, tiba hari ni nak tanya. Are you done? For B?
Yes.
Yes, madam.
Yes.
Alright.
Yes, madam.
Okay, alright. So let's discuss the answer. Draw the dative bond for the following structures. Okay, we have A, H3O plus. H3O plus is actually the reaction between, okay, we can assume, okay, it's the reaction between H2O and H plus. Okay, this one will form H3O plus. So we know that H2O, cuba draw H2O macam mana. So you akan dapat O, H2O macam ini. You ada dua lone pair dekat situ. Ada dua lone pair for H2O. Okay, and then we have H plus. Okay, so this lone pair can be used to form double bond with H plus. Okay, so if in proper we would get this structure. So one of the lone pair has been used, right? One of the lone pair has been used, so we have only one lone pair now. So don't forget that it will form the it will have charge. Okay, so this is a cation ion. So you may use, after all, they accept hydrogen juga kan. So you may represent the dative bond for any of the hydrogen available. So kita pun, katalah saya pilih yang ni. So from oxygen to hydrogen. Okay, alright. Okay, beryllium chloride. Beryllium chloride. Okay, so this is almost the same as what we had for boron just now. For boron pula. For aluminium just now. Okay, alright. So make sure that you have the Lewis structure for beryllium chloride first. Okay, kena tahu dululah dia punya Lewis structure dia apa. So lalu gedebak gedebu apa proses pampung dapat ni. Okay, remember dia ni adalah incomplete octet. Okay, right. So this is the Lewis structure for beryllium chloride. Okay, so maybe you can draw it as this ke, paling senang lah, the easiest. Okay, so you akan stack dia kan. Normally student would stack the, maksudnya stack atas bawah lah, ataupun dia side by side. Okay, alright. So this Cl, katakanlah from the first molecule will donate one of its lone pair to the beryllium. Okay, so dia akan form dative bond. So delete this one, please delete this one. Delete. Okay, padam. And then how about this beryllium? Okay, so this one will be accepting the electrons from the chlorine from second molecule. Okay, from this one. Okay, so delete and then transform to that. So there you go for your dative bond. And don't forget to label guys. Kena label. Label as in you kena macam ni tau. Dative bond. Macam tu. Dalam exam, kalau pun you buat macam ni arrow, kita tak, you kena assume yang examiners tak tahu apa. Okay, you have to label. Okay, label. So you have to label dative bond. Itu ada markah sini. Ya, begitulah rupanya. Okay. So alternatively, you buat sengit macam ni. Okay, sama juga. Dia cuma dia slanted a bit kan. Macam ke ada angle sikit. So this is how you your apa nama tu. Okay, notice any apa faulty on this drawing, on this structure?
Direction.
Direction yang mana? Yang number 1 ni ke ataupun number 2?
1.
Which is incorrect? Which one is incorrect? The number 1 ataupun number 2? So your answer just now is number 1. Okay, alright. So ingat, please ingat, it should come from the donor to the acceptor. Ini terbalik ni. Beryllium is the acceptor. Kenapa dia datang daripada dia pula? Macamkan dia yang bagi elektron tu. Okay, so it should be the other way around. Okay, it should be the other way around. Okay, alright. Alright, so jangan ingat answer semua betul so that's why you kena attend lecture, because during the lecture that is the time for kadang-kadang the correction will be made. Kita akan buat correction. So kalau you miss out, you tak tengok pula video, so you akan dapat, mungkin you akan ada info yang salah. Alright. Next is type of covalent structure. Covalent structure. This is in terms of structure, guys. It's not in terms of bond. Bond, we know that covalent means they share electron. The electron is shared between atoms. So that is what it meant by covalent. So now we are looking into the structure of the covalent compound. Alright. So normally, covalent structure, we have the molecular structure form, the normal one, we would call it as molecular structure. Normal covalent compound lah. Like SO3, HCl, H2O, what else? NH3. So these are considered as common molecular structure. Alright. Alternatively, we also have giant covalent structure. Jangan confuse, dia still ada covalent bond, tapi dia punya structure is what we call giant covalent structure. They are arranged, the atoms are arranged in such a way that they become a giant structure. Jadi besar. So that's why the word giant is used here. Example of giant covalent structure, we have diamond. These are the most common one lah. Diamond, graphite, silicon dioxide. Diamond, we know that diamond come from carbon. Graphite also carbon. Dia punya atom. It is made of carbon. Diamond also made of carbon. Tapi kenapa nama dia berbeza guys tu? Again, it depends. It depends on the structure that made of the diamond itself and the graphite. So diamond is arranged in such a way dia jadi besar dan strong. Dia punya bond tu stronger, maximize the strength of the bond. Tapi on the other hand, graphite pula dia terbalik daripada diamond. Tak silap saya dia disusun dalam bentuk hexagonal. You may refer it from the internet. Tak silap saya dia hexagonal hexagonal form. So this is carbon, dia ada 6 carbon form. And then imagine another hexagonal and then another hexagonal. This is carbon. So dia punya this is what we call attraction dia lah. So this is not as strong as compared to diamond. Tapi dia giant. Giant means dia adalah a pack of atoms arranged in certain structure punya form. Alright. This is the normal one, SO3. The melting point, as you can see, is lower, much lower compared to kalau giant covalent structure of diamond. Nampak tak? 4,000 and above. Kalau graphite is much lower than this one. Diamond is one of the hardest compound lah in the world, and it is used to cut something else. Dia digunakan untuk potong ataupun cut into smaller parts. Diamond. Right. Bond strength and bond length. Bond strength and bond length. So we have two properties that you should know here. So bond strength and bond length for the covalent bond. Just now we mentioned about structures. Saya pun tak faham dia lompat-lompat tu Balik kepada covalent bond, gitu. Bond strength dengan bond length. How do we identify the strength of the bond of the covalent bond and the length of the covalent bond? So let's go for bond strength dulu lah. Kita go for bond strength. The more electron two atoms share, the stronger the covalent bond. Okay, the more electrons two atoms share, the stronger the covalent bond. Okay. Bond strength is measured by how much energy needed to break the bond. Okay, so bond strength is measured based on how much energy is needed to break the bond. Kekuatan bond tu. Macam mana kita kata, okay, kita kata, oi, orang tu kuat lah, orang tu lemah lah. Based on what? Based on the energy that these two can provide in order to complete a certain task, for example. Okay, katakanlah okay, orang yang kuat ni dia banyak tenaga dia digunakan, barulah dia rasa penat. On the other hand, yang kurus kering, yang lemah ni, dia baru buat kerja sikit dah penat. Okay, so it is measured in terms of energy, and then from there we could say that we could measure the strength of the bond. Cool. Okay, so it's based on the more electron the two atoms share, the stronger the covalent bond. Okay, all right. So if we compare between the same atoms, the decreasing order of bond strength would be triple bond would be the strongest. Okay, triple bond would be the strongest, followed by double bond, and the weakest would be single bond. Like what we have here: C triple bond C, C double bond C, C single bond C. So C triple bond C has the highest energy. Okay, C triple bond C requires this much of energy in order to be broken. Same goes to C triple bond N, C double bond N dengan C single bond N. Okay, so kenapa bila banyak elektron share, the more they share electron, the stronger the bond become. Kenapa agak-agaknya? It is related to attraction. At the end of the day, okay, dia mesti ada kena-mengena dengan attraction. Remember, bila bond nak form between atoms, okay, dia akan share lah, katakanlah share kan, kata 3 electron, there are 3 bonds which equivalent to 6 electron. So siapa yang pegang, who held these bonds in place? Siapa yang pegang this bond supaya dia stay in place? Dia tak pergi mana-mana. Okay, dia stay in place, maksudnya dia remain dekat situ. Dia tak break, dia tak apa kan. So siapa yang pegang? Guys, agak-agak boleh jawab soalan saya. Siapa yang pegang this electron supaya dia tidak, dia stays in place, dia tak pergi mana-mana? Anyone?
Nucleus.
Yes. It's the nucleus, guys. Don't forget, ini adalah atom. So dia ada nucleus dia sendiri. We know that nucleus is positively charged kan, regardless lah berapa proton dalam tu lah, katakanlah. Okay. So lagi banyak proton, by right, the more positive it become. Okay, so this nucleus will hold this, what we call this bond. Okay, because these bonds are made of electron. So electron, we know that electron is negatively charged. Positive dengan negative, they attracts one another. So the more negative the bond, maksud more negative tu apa? Lagi banyak electron, that means lagi negative. Betul tak? Lagi negative the bond become. So the more negative, that means positively the nucleus lebih sukalah, dia sukalah terhadap negative charge. Okay, so the more negative it is, the more negative it is, the stronger the attraction between the two nuclei with the electron share. Faham tak? Itulah logik dia dekat situ. So ni kan ada 3 bond mean banyak lah electron. So means banyak electron, stronger lah attraction between the nuclei and the electron. So that explains why triple bond has the strongest stronger bond. Stronger bond. Maksudnya stronger bond means more energy is needed to break the force. Okay, because nuclei attracts better ataupun attracts more when there are more electrons. So lagi banyak bond, that means lagi banyak electron. Lagi banyak electrons mean the nucleus attracts more. Bila attract more, it cause attraction is stronger kan, so more energy is needed to break the bond. Okay, alright. So faham bond strength. Next will be bond length. Bond length is the distance. Okay, it's the distance between the nuclei. Okay, the distance between the nuclei of bonded atoms. Okay, alright. So itu dia punya jarak lah, dia punya gap panjang bond tu. Okay, so bond length decreases from left to right. So kita akan base on apa nama tu, the predictable punya properties, okay, across the period from left to right. Katakanlah all single bond, all single bond. C single bond C, C triple bond, C single bond N, C single bond O. Okay, alright. Even though they all have single bond, the same type of bond, but dia punya length, okay, dia punya length is different. Dia punya length berbeza. And then what caused that to happen? Okay, what makes this distance of bond different from carbon, nitrogen, and oxygen? Again, attraction, guys. Attraction across the period. Cerita apa macam topik 2 last time, across the period Z increases, betul tak? So when we go from left to right, the electronegativity increases, betul tak? So Z increases, electronegativity increases. I mean, the more electronegativity is, the stronger the attraction. Okay, the stronger the attraction. So oxygen is more electronegative than nitrogen, than carbon. Okay, so that's why attraction jadi stronger, dia jadi pendek. The bond become shorter. Okay, when we cross the period from left to right, the bond will decrease ataupun the bond become shorter. This is provided kalau you compare benda yang sama lah, period yang sama. Okay. And then kalau down the group, sama juga case yang sama, down the group the size become larger kan, we know that the size become larger, and then the electron become further away from the nucleus. Bila further away, sebab size dah besar kan, dia dah further away, so the attraction become weaker lah. Bila attraction become weaker, that's why dia jauh, dia menjauhi. Okay. Alright, so you can imagine, okay, saya tanya soalan. Between triple bond, triple, double, and single, which one is the shortest, guys? Which one will have shortest in length?
Triple.
Triple.
Okay, the longest?
Single.
Single lah kan. Okay. Okay, maksudnya you should be able to apa nama tu, to relate tadi bond strength in terms of order of the bond. The order of the bond we have single, double, and triple kan. So kalau dah triple tu attraction dia kuat. Maksudnya the more electron share, the stronger the attraction. Stronger attraction maksudnya it cause the bond to be shorter tau. Cause the bond to be shorter. Okay, kalau bond tu shorter, jadi bond tu jadi pendek lah. Bond pendek, more energy is needed to break the bond. Okay, so that is the relationship between bond length and bond strength in terms of order of the bond. Okay. Okay, arrange the following molecules in order of increasing bond strength. Okay, bila kita tengok dia bagi hydrogen, oxygen, nitrogen, macam tak perlu lukis-lukis je kan. Okay, looks like macam, okay, we can straight away, we can identify this order straight away. Macam tu, across the period, down the group, mesti nak buat macam tu kan. But, okay, please do not forget the order of the bond. Okay, the order of the bond. You have to identify. Sebab you nak eliminate. Okay, you ada dua factor tau dekat sini. Order of the bond. You have to identify. Dia ni semuanya single ke? H2 ni single bond Oxygen single bond. Nitrogen single bond. Kalau dia semuanya single bond, then only you can discuss in terms of across the period down the group tadi. In terms of length, the bond length just now. Kalau H, oh semuanya single rupanya macam tu. Nitrogen. Then in this case you have to mention in terms of bond length, because bond length will affect the bond strength. Okay, lagi panjang bond, by right the bond become weaker. Tapi betul ke dia macam ni? Betul ke dia semuanya single bond? You have to confirm this. Okay, in order to confirm this, you have to draw the Lewis structure for hydrogen, oxygen and nitrogen. Faham tak? So you kena go through that process. So hydrogen turns out to have single bond. Oxygen turns out to have double bond. Ini saya cut short You nak tahu, you kena buat, you kena draw. Okay, dia ada dua lone pair. Nitrogen on the other hand has triple bond. Tahu ke? Kalau tengok macam ni, rasanya ramai yang akan just across the period kot. Macam itu je kan. Z effective lah, tak apa-apalah semua keluar kan nanti kan. Rupanya you have to compare in terms of the bond order. Okay, this is single bond, this is double bond, this is triple bond. Bila you dah lukis baru nampak. Okay, then only you boleh cerita. Ni dah tak, ini maksudnya you kena mention in terms of order of the bond lah. Okay, so nitrogen, so by right siapakah yang having weaker bond strength? Increasing bond strength maksudnya kita kena increasing kan. Maksudnya we should start from the weakest to the strongest kan. So kita kena start daripada siapa? So which one is the weakest guys?
Single.
Single siapa?
H2.
H2. Okay, followed by O2. And lastly, we have N2. Okay, increasing bond strength. Jawab soalan. Okay, increasing bond strength. Kalau dia tanya, walaupun dia tak tanya reason, you justify. Sebab normally soalan mesti akan suruh justify. You have to justify. Okay, so you justify nitrogen has triple bond. Nitrogen has the strongest bond because nitrogen consists of triple bond. The more electron shared, the stronger the bond. That means more energy is needed to break the bond. Okay, ataupun yang sama waktu dengannya lah. Yang sama waktu dengannya. You have to mention in terms of bond order. Triple bond requires more energy in order to be broken. Nitrogen has triple bond guys. Okay. Ya, beginilah ceritanya. Alright. Okay, last but not least is the physical properties of molecular compounds. Okay, remember last time for ionic compound. Okay, lastly, when we have learned how to draw the ionic bond. Okay, lastly, we would conclude dengan the physical properties of the ionic bond ataupun ionic compound. So same goes to a molecular compound. Okay, molecular compound means compound having covalent bond. Okay, alright. Tapi dia belum habis lagi Ini just nak macam okay, we are done with the Lewis structure. How to draw the structure of molecular compound. Okay, so these are the properties of molecular compound. It's basically the opposite of ionic compound. Kalau ionic compound has higher melting and boiling point, But for covalent, okay, ini please be careful. Covalent, remember kita ada dah belajar dua structure of covalent, the normal covalent bond dengan the giant covalent structure. Normal covalent bond, they usually have lower boiling point and lower melting point because of the attraction between the molecules are generally weak intermolecular forces. Compared to ionic, ionic kan dia memang positif, memang negatif, so they attract stronger compared to molecular compound does not have that permanent charge. Okay, that's why they're weak intermolecular forces. There are forces but not as strong as ionic. But please be careful for the giant covalent structure. Sometimes ada ionic compound having lower, I'm talking about lower melting point or boiling point than giant covalent structure. Tadi tengok yang diamond just now has melting point of 4,000 and above. So banyak ionic, bukan banyak lah, ada ionic compound having lower melting point than diamond just now. Okay, so please be careful. Bila cakap molecular compound tu, you have to make sure what type of molecular compound ataupun what type of structure of molecular compound that you are referring to. If you are referring to the normal ataupun the common molecular compound, that means it has lower melting point. But if you are referring to giant covalent compound ataupun giant molecular compound with ionic compound, that one you kena be careful. You kena be careful. You have to look at the what we call that, dia punya trend dekat situ. Okay, contoh kalau yang biasa-biasa tu normally dia punya ionic compound, dia punya melting point tu not as high lah, not as high. Okay, alright. Number 2, do not conduct electricity. Kenapa it does not conduct electricity? Because this is the keyword, no free moving ions. Okay, opposite to ionic compound. Ionic compound pun you have to be careful, okay? Because ionic compound, if it is in solid state, it still cannot conduct electricity. So you have to be careful in terms of the phase ataupun the state that the ionic compound are in. Kena jaga-jaga dekat situ. Okay, kalau the ionic compound is in solid state, it still cannot conduct electricity. It can, in order to conduct electricity, it should be in aqueous ataupun in molten state. Kenapa it need to be in molten ataupun aqueous? Because of the free moving ions. Okay, but for molecular compound, definitely there's no moving ions. Okay, solubility. So ionic molecular compound basically does not dissolve ataupun insoluble in water. Dia tak soluble in water. Okay, but ionic compound mostly kebanyakannya dissolve in water. But ada juga yang tak dissolve. Okay, but normally they would dissolve in water ataupun soluble in water. That is for ionic. But for molecular compound, it is insoluble in water. Okay. Alright, so very quickly, cuba kita panggil nama. Okay, rasa takkanlah tak berjawab kan ni kan. Compare the physical properties between sodium chloride and CCl4 in terms of melting point, solubility in water, conductivity. Okay, alright. So, siapakah yang bertuah itu? Kita random je pilih. Pilih je siapa-siapa yang saya nak. Apa? Syahir lah, Syahir. Syahir Izzat. Syahir? Syahir? Tadang. Syahir, are you there?
Yes, madam.
Okay, Syahir. Alright, so let's look at the question. Okay, compare the physical properties between sodium chloride and CCl4. So sodium chloride is a type of, what type of compound of sodium chloride?
Ionic bond.
Okay, how about CCl4?
Covalent bond.
Yes, okay, molecular compound. Okay, we call it molecular compound. Dalam molekular tu ada covalent bond. Okay, molecular, normally we will go for molecular compound lah. Okay, in terms of melting point, can you please explain which one will have higher or lower melting point?
NaCl have higher melting point than CCl4.
Alright, okay. How about solubility in water?
NaCl soluble in water, while CCl4 does not soluble in water.
Alright, may I know why?
Because
Belum. Boleh. Okay, maybe we can go to conductivity dulu. In terms of conductivity, sodium chloride and CCl4?
this one I tak tahu madam.
Tak boleh. Dia tak boleh jawapan tak tahu. Kena jawab juga. Sodium chloride and CCl4, which one can conduct conductivity is most likely on electricity lah. Which one can conduct electricity?
NaCl.
Habis apa benda yang tak tahunya?
Tahu.
So sodium chloride can conduct electricity. How about CCl4?
Cannot conduct.
Why?
Do not have free moving ion.
And then how about sodium chloride?
Have free moving ion.
Are you sure what state?
State solid.
Are you sure that solid ionic compound can conduct electricity?
Dekat CCl4 yang tak boleh conduct kat
Ding. Apa dia? CCl4 apa tadi? Syahir, are you there?
yes.
Come again? How about CCl4? Can CCl4 conduct electricity?
Cannot.
Okay. Why is it?
Does not have free moving ion.
Okay. And then how about sodium chloride?
Can conduct
Can conduct electricity.
and
Okay.
state molten and aqueous.
Okay. You should state the phase ataupun the state that the ionic compounds are in. Sebab dia, kalau dia sodium chloride in solid state, sama juga, dia cannot conduct electricity. Okay, so sodium chloride need to be in aqueous or in molten state, liquid. In molten state. Then only it can produce ataupun provide the free moving ions. Okay, the critical part is the free moving ions. Kalau dia dalam keadaan solid, dia ada ions ada, but they are not mobile. Faham? Kalau you just kata sebab dia ada ion, sodium chloride pun ada ion apa? Tapi dia tak ada free moving ion. Ion ada, free moving tak ada. So that's why sodium chloride cannot conduct electricity. Okay? Alright. So this is the answer. Okay, thank you Syahir.
Welcome.
Lower melting point, high melting point, and then covalent compound is insoluble in water. Okay, ionic compound is soluble. Normally they are soluble in water. Okay, covalent compound for CCl4, they cannot conduct electricity. Even though in liquid ke molten ke, it cannot conduct electricity. But for ionic compound, nampak tak? They mention guys. You kena mention molten dengan aqueous. Kalau you just cakap sodium chloride conduct electricity, ayo. Okay? Tak boleh macam tu. You kena detail. You have to be specific. Can conduct electricity because they contain mobile cations and mobile ions pun should be okay. Okay? Alright, so that is all for today guys. Okay, so next, which is tomorrow, we will proceed with Vesper. So this is totally new. Okay? this subtopic and the next subtopic, these two subtopics are considered as heavy, berat sebab dia baru. Okay, so please be prepared for tomorrow's and also for Rabu guys. Okay, selagi kita tak come back on track, saya rasa kita akan ada additional class unless you are told otherwise lah, ataupun saya ada hal ke apa. Okay, so kita nak kembali on track balik. So hari Rabu ni kita ada kelas je. So saya dah lock hari Rabu kelas kita pukul 5.30 sampai 6.30 ke. Nanti saya set dekat appointment. Right? Okay. So please be prepared for this one for tomorrow. So we have one hour for our lecture. Okay, that's all. Any questions so far guys? Tak ada.
No, madam.